Okay, so this is a little bit of a silly example, but it focuses in on what the string builder is for, and it's using the same basic idea of my example with HAL and IBM. Uh, so here's a string builder, and you can have different constructors for string builders. You can just create one that starts like it's pretty much just an empty string that you can manipulate that's mutable, or you can create a new string builder that's based on an existing string. So it's saying copy this string, the characters in it, to a string builder object so that has the same letters. And that's the common thing you'll do with the string builder. You're like, okay, I need to manipulate the string, but I can't do it directly because strings are immutable. So I need to create a mutable version of the string. You can kind of think of a string builder as a string that's mutable, really. That's just kind of what it is. Now, if you look at the different methods, and you'll have to like look up all these maybe yourself and see what all the different things they can do. I'm just showing you the most basic one. You see, for one thing, you see it has fewer methods, but all those are used to like change the contents of a string. So again, you're copying a immutable string into a version of itself that's mutable, so you can work on it, the individual characters in it. You can't change the individual characters in a regular string, but you can in a string builder. And here's where I show how to do that. If you remember earlier, I had phrase sub I gets, and it had red squiggles because it's read only. You can't do that, but you can do that with a string builder. So string builders, I'm going to iterate over each letter in the string builder. Notice that it acts just like a string. A string has a length, the string builder has a length. I'm going to iterate over every letter. And what I'm doing, and this is kind of complex because I'm going back and forth between integers. If you think about how ASCII works, each character in ASCII is just an integer value. And what I'm doing here is I cast this phrase sub I to an integer. So I take whatever, say for example, A would be 65, capital A would be 65. It's turning that capital A character into the number 65. And then I add 1 to it, which makes it 66. Then I cast everything in this back to a character. So I can, and I have to do that because this has to be the individual elements of a string builder are characters. So because C# is a strongly typed language, you have to cast things when they are convertible very easily. And again, integers and characters are like convertible back and forth. You just have to cast depending on the context. In this context, you do have to cast. So what I'm saying is, what this is saying is take whatever letter it is and shift it over by 1. That's all I'm saying. And now assign that shifted letter over that I shifted over by 1 back to the string builder. So, and then in the end, what I do is I add the string builder to my list of items, but I convert it to a string. I don't know. This might be, I do this a lot because sometimes I get squiggles. But sometimes toString is implicitly called, and sometimes you have to explicitly call it. You can see in this case, it will implicitly call the toString method. It's never wrong to explicitly do it. It's just kind of wordy. You don't always have to do it. And it depends sometimes on your settings in Visual Studio, I think, too, whether it calls you out on it. But a lot of the time, you can implicitly make a call to string builder by just putting it somewhere where a string belongs. So really what you're adding to this are objects, but in any case, regardless, let's just run it and see how it works. So let's take our example, HAL, and submit, and you get IBM. So I kind of rambled after this point, and I'm not going to keep that in. It's a much more efficient video if I don't. The next videos I'll make will be starting with chapter 10.